Yes, beta. Good evening, everyone. Yeah. Ujjwal, Himank, Bhavil, Mithun. Yes. You people have given the exam? The last weekly test you have given? Good evening, Arun. Yeah. You can hear me, everyone? So paper was not uploaded on my ID, is it? Oh, that means we can't discuss the paper today then. Only maths, is it? Oh, there was maybe a technical something. So we'll just. So you have given the chemistry and physics paper, is it? You have given the chemistry and physics paper. Okay. Then no problem. We can just. So you have been marked for the same. You have been given the marks for the same. Yes. Okay. So I think separately we can't do anything, no? So not an issue. You can just maybe there may be some problem, but next test we'll make sure that things doesn't happen. Okay. So how much we can get it advanced by C? Let me make it very clear, Ujjwal. The ranking part, if you can do, see, we have modules, we have supplementary booklets, we have advanced package, right? There are a lot many books will be giving you, modules will be giving you. So once you complete the whole package, plus if you seriously give the exams, okay, if seriously give the exams, all India level exams, whatever we conduct, right? That also very religiously, it should be very punctual. You should be regular in giving the test, whatever the circumstances may be. And the students, you can expect, right? So your students who really do the sincere study of the VMC module of every level, right? So again, it depends upon your intelligence also, how you catch it. So I have seen people getting less than 2000 also, right? Rank in advance getting 2000. So our students have also given the 7th rank. You remember Aditi? Aditi got 7th rank, right? So they also started the things, completed the package, then given the test seriously. Okay, so you can expect around less than 1,000, provided you maintain around 70% marks in the VMC tests. 70 to 80%. Okay, right, Ujjwal? So I suppose you just maintain that 60% over barrier, right? I mean 80%, 75, 80% barrier always. You just cross that. It should be always like that. Every test you should have that. So that thing will definitely fetch you a rank which is less than 1,000. Okay. So, but school exam deviates me better. There are some deviations. Obviously, school exam is one of those deviations. So you have to work out, because this platform is very much friendly. You don't have to go to a center. You have to study from your home, whatever time you have. Yeah, the free time you have, you can study this, right? So yes, there may be some maybe you don't get time or get some, there's a confusion how to go about it, right? School part as well as JE part. But I suppose I always believe that if there's a plan, we can do it. So I think you should make a plan. You should dedicate a day for VMC, right? Maybe Saturday, maybe Thursday, whenever there is no class. Okay, and do your school work at school only. Try to complete your school work at school only, whatever time you get, because for JE you have to be very much, it's basically a tapasya, right? You need to meditate. Fine. Okay, so I suppose generally students who generally got good marks and good ranks, they generally complete the work in school itself, and they come to their place and just study VMC modules and whatever the school extra, if something has to be done, right? So I need to make a plan also. If in school you don't get time, then maybe you can assign a day for the same. That okay, school will study on Thursday and something. It should not be mixed up, right? Okay, Bhavin? So that is how it works. Fine. So I got a massive amount of worksheet in that. So can't you try it at your school also whenever you get some free time? So much. Yeah. Can't you try at your home, at your school also, if you get some time? Is it a possibility that you get it? So minimum daily study hours, I think 40 to 50 questions per chapter in maths in school daily. How it is possible? Achha. For me, every Saturday, 2 hours test is there. Okay. Someone says 40 to 50 questions per minimum. Achha, Bhavil says minimum. See, it depends. I mean, maths you can give 1.5 hours. Physics you can give 1 hour. Chemistry you can give 1 hour, right? Or you can interchange their part also, right? Not daily. Achha. If it is not daily, then it's okay. Yeah? It's okay. If it is weekly, then 10 question is okay. Samaksh, please send it on the group so that we can help you to. Yes, there are so lot many helping hands, right? Samaksh, there are helping hands, huh? Right. Yes. Okay. So this is how it works. I mean, we need to plan the things. Those people who plan it, it works for them, right? Fine. Okay. So today, so I have some doubts. Yes, we'll discuss those doubts. So few students have not given the exam doubts, I think, right? And the test in the on Sunday, last Sunday. Have you given the test last Sunday? Yes, is it? No? So is complex not completed? But a complex, the part 1 we have done till date. As I told you in the previous class also, complex is composed of 2 parts. So you have the module, right? You have the module, huh? You have the module, right? So there's a second part also. Second part where the geometry is involved. So there's ellipse. So what we have done, we have left it. Once we complete the coordinate geometry, then we'll do the complex number 2 part, right? Okay, Ujjwal? Because again, there should be some link. Otherwise, things become very clumsy, very confusing. Okay. So first we have the knowledge of conic sections, and that always makes you things much more easier then, right? So I was not able to give my test because I faced the same issue as Weibel faced. I don't know, maybe you write a mail or maybe you post your query on the group so that Nitika sir can tell you exactly what happened, right? So if there's an issue that need to be assigned. Yeah, Bhavel, I was there in the. So now which chapter will start? Ujjwal, we have started with function, right? We have given you the chapter, we have given you the videos also, right? So video is uploaded. Everyone, have you gone through the video? Have you gone through the video? Yes, question number 21, question number 22. They were uploaded today. So have you not gone through it? Have you gone through it? Not uploaded. Today at 3 p.m. they have uploaded. Okay, fine. No problem. We can just and the last functions, last week video function, have you gone through? Last week they have uploaded the videos, right? Acha, last video was demo-wise only. Okay. Fine. So they have uploaded today. So you can just go through the function once, right? They were uploaded. Have you gone through? Because it's uploaded at 3 p.m., right? So I think you people have not gone through it then. Okay then. Not yet, sir. Last video was demo-wise there. Okay. So it's okay. Then you just let's have a look at the question paper. So there was some mistake in the 1 or 2 problems, and that has been pointed out by our Samaksh, and that was really nice. So shall we discuss the paper today? Okay. It was a good paper, beta. Shall we start with the discussion on the paper, everyone? Okay. Question number 21. If x mod of x plus 1, right? I will just give you the hints how the things are, like why it was like wrong and why the options are not matching. We'll discuss that. Are the 3 terms of AP, okay? Then you have to find sum to 20 terms, right? This is what we need to find, okay? Right. So students, what we can do, because they are in AP, so we need to find the terms. We need to find the terms, right? So much. So we know that if ABC are in AP, we know that 2x plus 1 is equal to x plus mod of x minus 1, right? This is what we have, isn't it? Fine. I hope this is clear, everyone. Twice of mod of x plus 1 is equal to x plus mod of x minus 1, right? Fine. Twice of b is equal to a plus c, isn't it? Okay. So what are the possibilities we can have? What can be the possibilities we can have? So let's have, there are a lot many possibilities, right? Let's understand this part, how to go about it, isn't it? Right? Let's understand this part. Right. So the first case is case number 1. X plus 1 is greater than equal to 0, one part. And x minus 1 is also greater than equal to 0, right? These are the two cases. Case number 1. So in this case, what we'll have? We have 2x plus 1 is equal to, right, x plus x minus 1, right? Isn't it? This is how we can write it. Fine. Okay. So we are getting 2x plus 2 is equal to 2x minus 1. Does it make sense? Because this has to be cancelled. 2 is never equal to minus 1. This is case 1 is not applicable, right? Right, Samaj? Case 2. Let's understand the concept. X plus 1 is greater than equal to 0. X minus 1 is less than 0 bit. So that means we are having this as positive, right? This x will be always there, and this will be the negative part we'll take, isn't it? So we have 2x plus 2 is equal to 1. 2x is equal to how much? This is minus 1, right? X is equal to how much? Minus half, right? This is what we have. Okay. Then we have the case number 3. So case number 3 is what? We have twice of, x plus 1 is less than 0. X minus 1 is greater than equal to 0, right? This is what we have. Fine. And we write minus 2x plus 1 because the mod definition is equal to x plus x minus 1. This is what we have, right? So minus 2x minus 2 is equal to 2x minus 1, isn't it? So we have 4x is equal to minus 1. X is equal to minus 1 by 4, right? Then we have case 4. We have x plus 1, right? Because we have taken less than 0, no? So here also we can take is less than 0. X minus 1 also less than 0, right? So that means we take the negative part as twice of minus of twice of x plus 1, right? Which is equal to x minus of x minus 1, isn't it? So this become minus 2x, this become minus 2, this is x minus x plus 1, right? This is cancelled. So we can write it as 2x is equal to minus 3, right? X is equal to how much? Minus 3. Can you see that? Fine. So again, we need to, x is equal to half. So we need to check the domain also, whether x is equal to minus half is present here also or not. Right. That means we are talking about minus 1. We are talking about 1. So minus half will be here, right? So this is okay, isn't it? So it's good like this. It goes like so. The minus half lies here. So it is satisfying the domain, right? Okay. So x is equal to minus half. We can write. Got it? Is this clear, everyone? Fine. Okay. So this become minus half. So you can just check it out now. You got my point? This is okay, right? Everyone, is this clear? Is this okay, everyone? Can I have a confirmation, beta? And here also we need to check the domain. So x is less than -1, x is greater than equal to 1, beta, right? So x less than -1, x is -1, and this is 1. It domain comes out like this. So -1/4 lies here, right? So this cannot be taken. So we don't take this part. Got it? Case 2, sir, please explain. Case 2, beta, we have taken x plus 1 because we know the mod x definition, right? Mod x is what? X and x greater than equal to 0. Minus x, x less than 0, right? So we have taken the positive part. X plus 1 is greater than equal to 0 and x minus 1 is, right, less than 0. Okay? So x plus 1 is greater than equal to 0 means we are talking about the positive one, isn't it? X minus 1, that we take the negative one right away. Okay, so 2x plus 2 is equal to 1. It goes in -1. X is equal to -half. Got my point? Is this clear away? Right. Similarly, here also we need to check the domain again. It's very important to check the domain also. So this is -infinity to infinity, right? We have x less than -1. Obviously, this is -1. It goes this side, isn't it? And this goes this side, right? X is this goes this side, right? This again goes this side. Fine. So x is equal to -3/2 will be somewhat here. So this is also. Is this clear, everyone? Fine. Now it's okay. Now you can substitute the values and you can find the common difference, right? Yes. Is this clear? Yes, yes. Your answer is correct, beta. There was a mistake. The answer is coming out to be P. Right? Samaj, you're right. As I told you in the group, na, your option was correct. Actually, there was a misprint. Okay? So you did a right thing. Very good. Right, beta? Is this okay, everyone? Clear? Fine? No problem? Okay? Clear? So there was a problem with the question number 28 also. 28. So question number 28 was like question number 28. Okay, let's say question number 28. If Sn is equal to it's giving out to be n into n plus 1, right? N plus 2, n plus 3, doesn't it? This is what you have, right? And we need to find sigma r is equal to 1 to 10, 1 upon tr. Okay? So here, such type of question, sometimes they can ask you in this way also, within tr, root also, right? So generally what happens, we find tn like this way, tn or, tn, right? This is Sn minus Sn minus 1, okay? Right? So if I take Sn, it becomes n into n plus 1. This becomes n plus 2, n plus 3, right? Minus, in place of n, we write n minus 1, okay? I write n minus 1 plus 1. I write n minus 1 plus 2. I write n minus 1 plus 3, okay? This is how it goes. So this is n into n plus 1, n plus 2, this is n plus 3, okay? And this becomes, this is cancelled. So this is n minus 1, n, this is n plus 1, this is n plus 2, right? So n into n plus 1, n plus 2 can be taken common. We are left out with n plus 3, right? Minus what? We have n minus 1, right? This is what we have, isn't it? So this is n plus 1, This is n plus 2, right? This is how much? This is 4, right? So this becomes 4 into n plus 1 into n plus 2. It's going to be a... You understood this part? Tn is okay, everyone? Any doubts? Any one of you can just ask me, beta. This is okay, right? Yes, let me know, everyone. Samarsh? No, when you talk about 1 upon tr, right? So we are talking about 1 by 4 n into n plus 1, n plus 2, right? So this question I have given you, but let's understand this concept again. We need to separate it. We need to separate this part, right? This is what, isn't it? Then we need to put the values. Okay? How will you solve it? So basically, when you talk about this part, what does it mean? We need to, use partial fraction. We need to use partial fraction. Okay, that we have not done, but I would like you to go through it once, right? So if you know the partial fraction, things will be okay. So is the partial fraction known to everyone, beta? Is the partial fraction known to everyone? Is partial fraction known to you people? Yes, let me know if it is okay. Partial fraction is known to you? No? Okay. So basically, let me explain you the things, right? See, there is a method called partial fraction. Suppose you have been given 1 by n, n plus 1. Just understand this process, okay? N plus 2. We need to separate it. So I write it as a upon n plus a upon b upon c upon n plus 2, right? This is how we can write it. Fine. Okay? So I can take LCM, n into n plus 1, right? This becomes n plus 2, isn't it? And this becomes a into n plus 1 into n plus 2, right? Plus b into n plus 2, right? C into n plus 1, right? This is what, fine. And this is given as 1 upon n plus 1, and this is n plus 2, right? This is cancelled. So 1 is equal to a n plus 1, this is n plus 2, b into n, this is n plus 2, c into n plus 1. So we need to find the value of a, b, and c. Okay? All right? This is what we need to find. Got it? Now, how to go about it? If I want to get a, b, c are constants. They are constants. We need to find the value of this, right? Okay? This is what we need to find, right? Now, if I talk, we need to cancel b and c term. So that means if I substitute n, ये वाली पेज आना।
बटन क्या
Right. Okay, students. So I'm back. So we need to find A, B, C. They are constants. Okay. Right, everyone? Okay. Can you hear me? Yes. Yeah, perfect. Yes. Hello, beta. So n is equal to, if I substitute 0. So this term becomes 0, this term becomes 0, right? Because n is equal to 0, n is equal to 0. So what is left out? We are left out with 1 is equal to a, 0 plus 1, and 0 plus 2. Fine. This is what we have. Okay. So what is a? A will be twice a is equal to 1. So a is equal to half, right? Similarly, if I substitute n is equal to minus 1, right? So this becomes how much? 1 is equal to this 0, this 0. So we have b into 1 into minus 1 into minus 1 plus 2. So this becomes how much? Minus b is equal to what? 1. So b is equal to minus 1, right? Yeah. If I put n is equal to minus 2, so what do you get? We get 1 is equal to, all the minus 2 term will be cancelled, c is left out. So this is minus 2, this is minus 2 plus 1, which implies 2c is equal to 1, or c is equal to how much? Half we have, right? Can you see that? Okay, everyone, is this clear? What is the purpose of this method? It's a very important thing, because if I take this part, if we can make it separate away, things becomes much more easier then. So how to know what to substitute? Because n plus 1 is there, na beta? N plus, so we need to check the factors. According to the factors only we need to act. According to the factors we need to act. Right, so much? So here n is there, right? N plus 1, n plus 2 is there. So n plus 1 can be written as n is equal to minus 1. N plus 2, n is equal to minus 2. N is equal to 0. We can write in this way. Isn't it? Okay. So n is equal to 0. N is equal to minus 1. N is equal to minus 2. So we have these parts, right? Fine. So we can substitute in this case. So basically it's a substitution method where we can use. So we can write it as what? A is what? A is given as half. So I can write it as half. And can you see that? I've separated it. Fine. Yes, Aryan, Karan, Abhi, is this clear, beta? Everyone, Himak, Nitya, Bhavil, Parul, Ravisha, Samaksh. Yes. So this comes out to be B. B is what? B is minus 1 divided by n plus 1, right? C is what? Half n plus 2, isn't it? This is how it goes. Fine. Okay. So it is useful for infinity, no beta. It is not for infinity. It is for the number of terms. So they have asked that in the question, we need to find sigma r is equal to 1 to 10. Okay. 1 upon tr, right? So that means we can see how the terms can be worked out, right? So this, maybe some terms will be cancelled, you know. That is what the logic is all about. If you put, you know, it's a lengthy sum, 1 by 1, 1, 2, minus 1 upon 2, plus 1 upon how much? We have 2 into, you know, it comes out to be say 1 plus 2, right, Samaksh? Plus 1 by 4 can be taken outside, right? So already 1 by 4 is there. So whatever the terms you'll be getting. So you can see that terms will be cancelled, right? I think the logic is clear now. So you can do the calculations. Yes, everyone? Can I have a confirmation? Right? Yes, right? Okay. So this is how it works. Okay, it's a lengthy sum. The same type of sum is there. If it is root TR, then also we need to, take this method, use this method only, right? Okay. What was the, so I want everyone to go through it once. Okay, and do the calculations. So we'll put 10. Yeah, you can go through it. We'll get a sequence like that. Unless it will be a very lengthy calculations, because r is equal to 1. It cannot be so easy. It's not so easy calculation, right? Fine. So question number 29. You can't have a shortcut in this, right? So we need to do it like 29. What is the 29 question? Question number 29 is basically, this is again a very interesting one. I mean, question number 29, very interesting question. We have been asked to find the nth term, right? Nth term of 10, 23, 60, 169, 494. This is. Okay, this is how it goes. Fine. Nth term of 10, 23, 60, 169, 494, right? This is what we have. Fine. So, is this an AP, my dear students? Is this an AP? Is this an AP or a GP or HP? Is it? No, right? So it is not. So we can cancel this part. It is not an AP. Is that? Yes. Test question. No? Fine. So how to go about it? Nth term of 10, 23, 60, 169, 494, AP, GP, HP. They are not AP, GP, HP. So can we go into the difference of terms? Can we have the difference of terms? That is again what we have done in the previous, in the class, if you remember. Let's find the successive difference now. Successive difference. Now successive order difference we call it, right? So what is the difference we get? 23 minus 10 is how much? 13, isn't it? If I subtract this, how much we get? 27, right? So 37, isn't it? If I subtract this, how much we get? We get how much? 160 minus 60 is 109, right? Can you see that? This minus this, 494 minus 169 is how much, my students? Please tell me. This is 169. So what is the answer? $494 minus 169 is how much? Is 335, right? Okay. Right, everyone? Can you see that? Now, is this in AP or GP or HP? Is this in GP, HP or AP? No, right? Again, this is not. Now, if I go to the second order difference. Second order difference means successive bits, second order sum. What is 37 minus 13? 37 minus 13 is 24, right? 10 minus 37? 72. 335 minus 109? 216, isn't it? Can you see that? You got it? 226 or 216? 216, is it? 335, let's have a difference like 109, right? So we have how many? 6, 1. 2 to 6, is it? Okay, 2 to 6, fine. Right, so just have a look at it. Let me know if the calculation is okay, everyone. Fine. So here we should get something. We need to get something better. This is a GP, right? Is it? Great. Right, so much. So this is coming out to be a GP. Fine. So if second order is GP, if the second order is GP, then we take Tn to be A into R to the power n minus 1 plus Bn plus C. Right, this is what we have. Got my point, everyone? Okay. Right, so these are the terms. Now, a bit of calculation. What is ABC? Let me first of all tell you that ABC are constants. I've given the exam in the this question in the test so that I can discuss it in the class, because discussing in the videos sometimes becomes clumsy. So I have taken this question. That's why, just to make you realize that okay, this type of questions are also there. First order I have done in the class, right? So what we do, if I take T1, Achha, what is R? What is R? Anyone can tell me what is R? R is 3, right? Everyone, fine? So that means we are talking about a T1, right? So this is a 3 raised to the power 1 minus 1, right? Plus B into 1 plus C, which is coming out to be A plus B plus C is equal to 10, right? Right, Aprajit? Is this clear, everyone? Fine. If I go for T2 method, what is T2? We put n is equal to 2. Where? Here, right? And what is T2? T2 is 23, isn't it? So this becomes A 3 to the power 2 minus 1 plus B into 2 plus C, right? And this is coming out to be 3A plus 2B plus C is equal to 23, isn't it? So this is equation number 1 and this is equation number 2 we have, right? Then we have n is equal to 3. T3 is equal to, we have 60, right? Which is nothing but A into 3 raised to the power 3 minus 1 plus 3 into B plus C. So you get 9A plus 3B plus C is equal to how much? 60, right? This is what I got. This is the third equation. I hope this is clear. Fine. So we get the value of A, B, C in this case. We can take, what we can take? We can first of all, we can eliminate any one of the variable from this equation, first and second equation. Then we can eliminate second and third. We can eliminate any, whatever the elimination we have done, whether C or B. Second and third also, if it is from first and second equation. from first and second equation, if we eliminate C, then from second and third equation, we need to eliminate C. We need to eliminate C. We need to eliminate C, right? This is fine. Fine. The first order too, we have done it, now. First order. That we have done, now. That formula we have used, now. Yes, the nth term will come up. If we find the value of A, B, C, we get the nth term, right? Got it? Everyone, is this clear? Fine. If the first term, first difference is a constant, let me first of all ask, there was a question asked by, the Tn can be taken as, Aryan, An plus B, right? It's the first difference, right? You are talking about the first difference, huh? The formula is this, if the second difference is a constant, right? Can you see that? Second order difference. Right, Aryan? This is the thing we have. If the second difference are constant. If the first difference is constant, then Tn is An plus B. If the third difference is constant, right, then we take Tn is equal to An cube plus Bn square plus Cn plus D. Okay, this is also you can write. Fine. So we have to solve for A, B, C. Yes, Samash, you need to solve it, right? From 1 and 2, we eliminate C. A is equal to, we need to see maybe A is equal to, I think it's coming out to be 6, is it? 3. B is equal to 7. So where is R? No, we are. See, this is for. Let me. Okay, wait. I will just give you the clear example of that. Right. I will come to the next page. First of all, tell me it is clear. I will come to that page, Aryan. Is this okay, everyone? So can you solve for A, B, C? Yes. Ujjwal? Yes, Aryan? Yes, Imang, Samaj? Everyone? Okay, I will give you a very short formula for the same, how to go about it. Okay, don't worry. Right. Fine. Okay, let me go to the next page now. Now, the formula we have, as you told me that, so what can be the formula, right? First, if the first difference, you can just, all of you can write it down. If the first difference are constant, right? So we can take the general term to be Tn is equal to An plus B, right? If the first difference are constant. It's not in GP, we are talking about a constant, right? Yeah. If the second difference are constant, then Tn is equal to An square plus Bn plus C, right? If we have the third difference are constant, right? Then Tn is equal to An cube plus Bn square plus Cn plus D. Okay. Fourth, if the first difference are in GP, then the general term will be Tn is equal to AR to the power n plus B, right? You can write it down, Aryan. I'm coming to the point. If the second difference are in GP, then Tn is equal to ARN plus Bn plus C, right? 6. If the third difference are in GP, then Tn is equal to ARN plus Bn square plus Cn plus Dv, right? This is clear, Aryan? So you got the formula now? Is this fine, everyone? Yes, please give me a confirmation if this is okay. So all the cases we need right, we need to find A comma B comma C dot dot whatever by putting n is equal to what? 1, 2, 3, like this, fine. But in GP difference, no, I'm not talking about GP, it's common ratio. Oh, okay. First, no. First difference are in GP with common ratio R. This is what I'm talking with common ratio R, right? With common ratio R, right? With common ratio R, okay? So R to the power n minus 1 is the last page. This is what we have, ARN right. It has to be ARN, right? ARN minus 1, yes. Okay, just rectify this part, come on. You can find the general term in this case. The common ratio can be taken, right? We have been given AR n minus 1. What was the option given? 2 into. Yeah, just rectify this part, right? We get AR n minus 1. Okay, this is what you can write. Fine. Yes, right, Aryan? So these are the shortcuts we can have where we can utilize the part, right? Okay, any other questions you have? Any other queries? Yes, let me know. Fine. Yes, students, let me know better. In the test, so page number 4 is the first 4 formulas for summation on board for? Yes, beta. These are all summation board, right? Whatever the questions will be given to you, this is for TN, actually, not summation. Yeah, once you get the TN, we can find the summation. But TN summation is a very difficult task to find, right? They will ask you the question, find the nth term. Okay? Right. No. These are all in the summation, Navita. All are given in summation, sigma Tn, right? Sigma Tn, isn't it? So this is obviously summation, right? All we are talking about summation only. But these are the form of nth term, right? These are the form for nth term. Obviously, once you put the values, you'll get the summation. We'll get the sum, right? Okay. So everyone, please give me a confirmation. Shall I go to the next part now? Yes, everyone. Anak, Sakshi, Parul, Ujjwal, Aprajit, Jai Kishan, right? Karan, Ritesh. Yeah. Okay. So I think we need to the second difference, right? So I'll just any other queries, anything, or shall I go give you some questions? With functions, have you gone through it? Yes, let me know, beta. Yes, everyone. Yeah. Yes, yes, we are including class 12th also. Don't worry. So much. Other students, let me know, beta. If this is okay, everyone, shall I go to the next part? Or shall I give you some questions based on this? Shall we discuss something? Okay, if there is no doubts, so I can discuss functions. So complex number, I think we have discussed the doubts and all, right, everyone? So can I have a confirmation, beta? Right? Functions? Everyone, function? Right? Okay. Now, when we talk about the function part, right? So let's start with the function. Okay, let's understand what is the function, and then we can do problems based on this. Okay. Now, when you talk about a function, so first of all, let's understand what is a function. If we have two non-empty sets, A and B, right? Okay, and f is a function from A to B. F is a function from A to B, right? This is what we have. F is a function from A to B, we have, right? So what does it mean? It means that for every x, there is a y, isn't it? For every x, there is a y. So that means if I talk about you know, A and B, I'm talking about a function f. So is this a function? Is this a function? Yes, students, let me know if is this a function? Right. Okay, this is a function, isn't it? So if I take, this is an example number 1. If I take example number 2, I have A and B, right? I have this, I have this, right? Is this a function? Is this a function? No, it is not a function. It is not a function, is it? No. Fine. Okay. No, because there is an element which is left out. So this is left out, right? So it is a relation. Absolutely. So example number 3. If I have two sets, A and B, right? There is an element which is connected to this. Is this a function? Is this a function? How it is a function? Function is what? Function is every element of A, right? Element of A is connected to unique element of B, right? Every element of A, yes, fine. So this is not a function. X has two images, right? It is not a function. Got it? Everyone, fine. So, but pre-image can have two images. Yes, it can have, but I'm talking about a function from A to B, right? I'm talking about a function from A to B. Fine. Not B to A. Now, if they have asked you the question like f is a function from B to A, suppose, right, Aryan? Then it is a function, isn't it? Then it is a function. We can say that it is a function, right? But A to B, it is not, right? Okay. So example 3 is not a function. No, beta, it is not a function. It diverges, right? You can see it diverges. Okay. So basically, when you talk about a function, function is represented, again, this is an arrow representation, diagrammatic representation, right? Why example 4? I have not given any example 4 now. Example 4? No. Example 4 in the sense that if they have asked the function is from B to A, if they ask you that the function is from B to A, then it is a function, right? Then it is a function, isn't it? Is this clear? Right, Samaksh? Then no, then again this is left out now. It cannot be. If they ask you, sir, is B to F function is from B to A is a function? No, beta. Because every element should be connected. Every element should be connected, right? Fine. Every element should be connected to a unique element. Okay? No, I have taken it, beta. I have taken it. Example B by 4. See, why it is? Because there is no element which is left out. In example number, if we take the function from F B to A, suppose, right? F is a function from B to A, suppose, right? B to A, suppose, isn't it? So we can see there, we have Y1, we have Y2. This is X, isn't it? So this is what? We can have that function, no? No element is left out. In this case, the element is left out. This element is left out, right, so much? No element should be left out, okay? So that means we are talking about something. If I talk about f is a function from A to B, it means we are talking about a function, right, from A to B. So it will be like f is a function from A to B. It is like that. So if every element is connected, but one image is left out, image can be left out. Image can be left out, beta. Right? But every element of A, should be connected. Right? Should be connected to the elements of B, unique elements of B, right? Unique element. Okay? Fine. Abhi, it is important both? No, but not necessarily. It is not important. It is not important. right? It can have a different number of elements, no problem. Fine. But again, one is what is pre-image? See, if I talk about a pre-image means we are talking about, suppose this other two sets, we have A to B, right? This is a function from f A to B. So you have x, for x1 we have y1, right? For x2 we have y2, isn't it? This is what we have. Fine. So these are called pre-images, right? These are called pre-images, beta. Elements are obviously elements are pre-images, right? Elements are pre-images, and these are called, you know, if this has an image like this is an image like this, so these are called images. Okay. There's a question from Ayush. So if which one? Okay. Ayush says if there's a single element of in A, it shares 3 different images. No, sir, it will not a function. Ayush, if there are 2 sets A and B, and we have a single element in A, right? So this is not a function, right? Can one pre-image can have 2 images? No, same question, Aryan. It is not. It cannot. The function existence of function is not there then, right? It is not possible. Then see, it is a one pre-image, isn't it? It is one pre-image, isn't it? One pre-image cannot have 2 images, right? Isn't it? Right? I think this is clear to everyone. Samaksh, you want the previous board? Everyone, please confirm. Yes, which part? Samaksh, the things are not clear to you. Can you just tell me? Yes. Example 2 is not clear. Beta, if the elements are left out in set A, then that is not a function. If the elements in set A is left out, then the function is f is not a function. Okay. Right. So it is not a function. This is not a function, right? So 2 elements on the same ring. Yes, if we have 2 elements, and 2 elements are connected to B, but 1 element is left out, then it is not a function. Okay. Okay. Let me give you some. Again, let me give you some picture where things will be clear. Just have a look at it. See, I will just draw a few examples. Wait. I will give you some examples. Right. Wait. Right. We'll give you some examples. Okay. Let's have a different types of examples. Right. Don't worry. Wait. And tell me if this all are, functions or not, right? So what happens is, like, if we have A, we have B, okay, and f is a function from A to B. Suppose every case we have A, we have B, we have A, we have B, right? This is A, this is B, 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 isn't it? This is how it works. No? Right. Now, if I have 2 elements, 3 elements, we have 1 element. Suppose this is A1, this is A2, this is A3, right? This is B1, this is B2. A1 is connected to B1, A2 is connected to B2. Is this a function? Is this a function? Abhi says yes. Huh? Mithun says yes. Is it? Is it a function? It is not a function, right? Because the elements are left out. A3 is left out, beta. It is not a function. It's left out, no? Right? This is the first one. Okay? Second part. I have A1, I have A2, I have A3, I have B1, I have B2, I have B3, I have B4, right? This is connected to this, this is connected to this, this is connected to this. Is this a function? Is this connected? Is this a function? Yes, it is, right? It is. Before elements in B can be left out, no problem. Elements in B can be left out, no issues, right? Left out. This is no and this is yes, right? Left out. Fine. Now, if I talk about A to B, I have A1, I have A2, I have A3, I have B1, I have B2, I have B3, I have B4, right? This is what it is, isn't it? So A1 is connected to B1, A2 is connected to B2, like this is connected to. So this is also a function, is it? It is a function. Yes, so A1 has the image B1, A2 and A3 has the image E2. They don't have two images, no? So it is a function. Yes, it is a function. A2 has an image. A3 is also a same, unique image. It is a function. Right, Samaksh? Right, Aryan? Nitya? Okay, so there's a common, yes, it's a common image we have. We can have a common image, right? Yeah, from B to A also, Abhi, no problem. It can be left out, no issues, right? So we have B to A. Yes, it is. So we have B to A, right? B to A we can talk about, but okay, fine. We should not. We'll discuss later on. First of all, you discuss about A to B. B to A is a different thing. I mean, same logic, but I'm talking about A to B. Let's take the different cases of this, right? So I think this is okay, everyone. This is a function, right? So we have this, we have this, right? We have this. Is this a function? Is this a function? Fourth one is a function? Yes, sir. Absolutely, better. So this is a function. No problem. Fine. One element is connected to this element. Is this a function? Fourth, fifth one? Is this a function? No, because they should have a unique image, right? A1, this is B1, this is B2, doesn't it? As a unique image, right? But A1 has two images. Image, the image A1 has two images, right? So that means not a function. Let's come to sixth part. So when you talk about 6, what does it mean? What does it mean? It means A to B, we have an element A1, right? We have B1, we have B2, we have B3, okay? We have A2. Can you see that? So if the element, both the elements are left out, then also it is a function, isn't it? No problem. Both the elements in B is left out, so it is a function. And these two are connected with this. You got my point, everyone? Fine. Now it's clear, right? The definition is clear now. Everyone, please confirm if the thing is okay, right? So, different types we can come across, right? Okay. Now, students, what we have. So this is what we have done is basically is a diagrammatic show, right? This is how we write it, isn't it? So basically we are talking about A, we are talking about B, right? So there's a function from A to B. Right. So if there's a X, there's a Y. If there's a X1, there's a Y1, there's a X2, there's a Y2. So basically we talk about like this, we can write it in ordered pairs. One element cannot have two images, but two can, yes, one element cannot have two images, but two elements can have the same image. Absolutely. Okay. Okay. So ordered pairs or coordinate form is very important. So how we can write it, let's understand. Okay. Suppose we have X1, Y1, we have X3, this is Y3. So this is what is cancelled. So sorry, not cancelled. Let's just write it down. Say this is a arrow diagram. Okay, what you have written. So if we have been asked to write it in the form of a ordered pair or a coordinate form, how will you write? You write in this way: F is equal to X1 Y1, right? X2 Y2, fine. X3 Y3. Okay, this is how it write. Fine. Is this clear, everyone? If we have been asked to write it in the ordered pairs form or coordinate form, we can write it this way. Okay. Now, again, it's a very interesting concept comes into picture. How to identify graphically a function, a given graph, a graph is a function or not. So is this form applicable only for elements in function? Yes. Or relation to. Relation also we can write in this way, right? Okay, this is it. So that test is called the vertical line test. We call this as a vertical line test. Suppose we have been given a function. We have been given a curve. We need to understand whether this curve is a function or not. Suppose, let me take this graph. Okay. Right. Let's understand. Let's take a very simple example, and I think things will be okay. Fine. And let me draw one more graph like this. Okay. Right. This, isn't it? Like this. Got it? So my question is, is this okay? AV is okay, beta. Audio video is okay, everyone. Is this problem? There any problem? So much. Now it's okay. So how to identify graphically a graph is a function or not? Right? Okay. So how to understand this part? So what we can do, we can draw a line, perpendicular line, vertical line, right? Can you see a vertical line I'm drawing? No? These are the vertical lines I've drawn, right? Fine. Okay. So here, when we talk about a vertical line, so let's understand what exactly it means. Fine. Let's see. Graph A is when you draw a vertical line, for every x, there's a different y. Can you see that? For every x, there's a different y, right? For every x, okay, there's a different y. Fine. I'm talking about a vertical line test, whether to identify whether the graph is a function or not. Okay. So vertical line test will be a thing which will be taken into consideration, right? So when you draw a vertical line, you can see for every x there is a single y. For every x there is a single y. For every x there is a single y, right? For this we have a single y, different y, right? Different y, isn't it? For this we have a different y. So this is sin x. This is a graph of sin x, right? Yes, this way, sine wave. Okay. So if the vertical line, what is the vertical line test? If the vertical line cuts the graph at one point, then the graph is a function. Okay, graph is a function. Fine. Is this clear? So if I apply the same rule in the second part, is this a function? Is this a function? If I use the part vertical line in the second part, is this a function? Can you see that? No, right? Right side. Very good. Ravisha. A is a function, but it is not. That means we are talking about A. Suppose this is x. So this is one y we have. Then we have the second y. We have the third y. Right? Can you see that? So for every x, one x, there are different y's. Is this clear, everyone? Is this okay? Any problem? For every x, there's a different y. Beta. The vertical line test means we are talking about this is y, this is x, this is x dash, this is y dash, right? This is what we have. Fine. Okay. So I'm drawing a vertical line through this curve. So for every x, you can see there's a y, right? For this x, we have one more y. For this x, we have one more y, right? Can you see that? Yes, y is an image, na? For this x, again, we have one more y. Again, wherever the point of intersecting is there, so this is one more y. Got my point? See, let me take an example. If y is equal to x squared, say x squared is equal to y, right? And this is basically a graph. This, right? Can you see that? Is it? So, is this a function? Is this graph a function? Is this graph a function? Yes, no, yes, no. Is this? So what is the logic? I drop a vertical line, right? When you talk about a vertical line, what does it mean? It means that we are drawing a perpendicular line to the x-axis. So there is x1. So for this x1, there is y1. 1 y1. Same for x1, we have different y2, right? Can you see that? So if I talk about a function, we have x1, y1, we have x1, y2, right? This is how we do it, fine? Isn't it? This is how it works, right? Okay. So what does it mean? It means that if I put x is equal to 2, I get y is equal to 4, right? If I put x is equal to minus 2, I get y is equal to 4. So that means we are talking about a function graph like this, where for x 2, we get this as 4 and this as minus 4. For same x, we are getting two different values. So is this a function? It is not. So if it cuts at one point, then it is a function. If it cuts at 2 or more points, right, it is not a function. Got it? It is not a function, right? Is this clear, everyone? Fine. Ayush, Ujjwal, yes, let me know. Anak, Sakshi, Parul, Jai Kishan, Nitya, Samaksh, Sukantan. Yes. Fine. So 2x can have the same y. Yeah. So that is not a function. 2. No. Here it is 1x, no? Sorry. I think. Wait. X squared. This. Wait. This graph. Wait. Just a minute. Just a minute. I've taken the different graph. Wait. So yeah. If we have y square is equal to x. If I have y square is equal to x, right? So let me take the example in the different board, right? Let's take the two different. Just a minute. There's a confusion. Wait a minute. I will take the example in the different board. Okay. Let's understand this one. Fine. Okay. Let's take it in this way. Wait. I'm coming to the point, beta. Just a minute. Huh? I'm taking a different example in different board altogether. Okay. I have. This is the origin, right? So this is what? This is a graph which is y square is equal to x. Okay. Right? And this is a graph which is x square is equal to y. This graph. Let's come to the point. I think that there we have done a big mistake, the calculation part. So just avoid this. I will come to the point. I'm coming to the different board now. Can you see that? Right? Is this clear? Now, Samaksh, I think I should come to the point now. Is the first one a function, my dear students? Any one of you can tell me if the first one is a function? First graph is a function now? Is the first graph is a function? Is it? No, because there is a x which has 2y, right? It is not. Fine. It is not a function. Is it a function? It is a function? Yes, this is a function, right? This is the origin we are talking about, right? So for every x, there is a y. Can you see the only one point, right? Okay. Nice. Okay. Is this clear, everyone? Fine. No problem. Every student, please confirm. Is the concept clear? So every graph cannot be a function. Every graph may not be a function, right? So this is what it means. Isn't it? There's something to be followed, right? There's something to be followed. Fine. Is this okay, everyone? Okay, fine. Now, if I come to a concept like how to find the domain, how to find the range of a function. Again, if we have A and B, there are two sets, right? This is a function f, right? If I have x1, I have x2, I have x3, I have x4, right? I have y1, I have y2, I have y3, I have y4, like this, isn't it? So this is joined with this, say, this is joined with this is joined with this is joined with this, right? So in this case, the domain is set A. Codomain is set B, right? Range is, we have y1, y2, y3. Isn't it? This is how it goes. Fine. This is a domain, range. Okay. This is y1, this is y2, and this is y3. We have. Fine. Okay, everyone, is this clear? Domain is the set element, all the set of pre-images, right, Arish? Set of pre-images, right? Or inputs, we call it. Fine. Set of images or outputs, we call it, isn't it? Sorry, this is set of images. The range is basically set of images, and the codomain is the whole set B. Whole set B is the codomain. Fine. Right, everyone? Is this clear? Any doubts, beta? Any one of you can tell me? Yes, everyone? Fine. Now, this is again a very simple one. We can draw the diagram and you can find out. But if the diagram is analytically, we need to find. Simply, you have been given a functions, right? Say type 1. Let me give you type wise. It is already done in video, but still I will do it so that things will be much more clear. Okay? Type 1. You have been asked to find the domain of the function fx is equal to right? Fx is equal to, say, let me take px upon qx, like this is the form, right? So when you talk about the domain, let's understand what is basically the domain, right? Because this is diagrammatic show, but when you talk about domain, what exactly the domain is? Domain is the collection of all inputs. Domain is the collection of all inputs, right? All inputs. Okay, this is domain. For which inputs means we are talking about the values of it, for which the y is defined. Okay, y is defined. Fine. So this is type 1. So here, when you talk about a domain, qx should not be equal to 0 whenever there's a rational expression, isn't it? Okay. Suppose we have y is equal to 1 upon x minus 2. So here the x minus 2 is not equal to 0. X is not equal to 2. So that means the domain will be how much? Domain will be r minus 2. Fine. This is the domain we have. Got it? Yes. Right? Similarly, when you talk about type 2, we have root of fx. So whenever we have a root thing, fx is always greater than or equal to 0. That we have to take. Then we have type 3, right? Type 3 is log of fx. So that means fx is always greater than 0. Okay? Got my point, everyone? Type 4. So you can learn the domain. If there's a trigonometry thing, sin x can be written as r. Right? Cos x, it can be learned. Okay? Type 4. Is this clear? Right, everyone? Any doubts? Any one of you? Yes, let me know, beta. Okay. Let me take few examples, and things will be much more easier, right? I take the first example as 1 minus x, right? The second example is y is equal to, say 2 to the power x suppose. Third example, y is equal to log, okay, x, right? Fourth, y is equal to, we have 2 sin x. 5. Y is equal to, we have under root of 1 minus log base 10x. Okay, this is how we try. Now my question is, how do you find the domain of this? Then we have one more. Y is equal to under root of 4 minus x squared, suppose, right? Y is equal to 1 upon x plus mod of x. Okay, so how do you solve this one? Come on, try. I'm giving you 3 minutes. Just try. Just give a try. Yeah. Got it? Again, mobile. What type of question it was, Mitchell? Because I don't have the mobile with me now. Like, if you can give a hint so that it's related to function. If you can type it down, that will be fine. Here what happens, you have 1 minus x is greater than or equal to 0, right? 1 is greater than or equal to x, or x is less than or equal to 1, fine? So that means we are talking about minus infinity comma 1, right? Isn't it? The first one is okay, the domain is fine. The first 2 to the power x for every value of x. So I think the domain will be R in this case. You can take any R, right? Any R, right? Log x. Log x, because log x is defined only for positive x. So it will be always R plus. So domain is R plus, right? So if a graph is given, that will you have to find all the possible. No, we can't tell what type of function it is now. If it is a known function method, it is okay, because we know what is the circle and like what is the ellipse, what is the hyperbola. This all things we know. But find this. Find the possible number of functions. So that means that graph is a function. That is one to many. So this the first thing is clear that it is a function, right? The graph is a function. So that again, it depends now what type of. So because first element can be connected to n elements, right? So it can be like if there are r elements, it can be written as n to the power r functions then, right? The possible functions can be like that only, no? Suppose you have two sets, right? Return, yeah. So one set elements you have say n elements, and there you have r elements. So each element of A will be connected to the elements of B in r ways, right? Isn't it? So n to the power r will. right, Mithun? Okay, I will come to the point. That point also, don't worry. This is R plus. Here also the domain is R. Just have a look at it, everyone. Domain is R, right? Here, because within the square root, so we can write it as 1 minus log base 10x is greater than equal to 0, right? So we have log base 10x is less than equal to 1. X is less than equal to 10 to the power 1, right? So x is less than equal to 10. So that means we are talking about minus infinity comma 10, and this is close. Got it? Fine. So this is the domain. Okay? You can just check it out, everyone. 4 minus x square, again it is root. Okay? Again, there is a very interesting question they are asking. One more thing we need to wait. It is the domain. Is this can be a domain? It's a very interesting one. Yes. Is this going to be a very, it can be a domain? X, again, one more thing that I have left, they have been left out. So just have a look at it. It's a very good question asked. X we got. But one more thing is very important, that X cannot be negative, right? X is always 0. So there are two things. We need to take the common part. So we have minus infinity to infinity. This is 0. This is 10. We have 10 here. Go like this, right? So can you see the common part? What is the common part we have? We have 0, 10, right? Right, Samaj? Is this clear now? Log x can be taken. Log x can be negative. Log x can be negative, but log of something cannot be negative, right? That is what the logic is all about. Fine? Right? So domain is what? 0, 10. I hope this is clear to everyone. Fine? Is the domain okay? Abhi? Yes? Ayush? Samaksh? Sakshi? Parul? Anag? Nitya? Ayush? Abhi? Aprajit? Yes, better. Mithun? Aryan? Saksham? Samaksh? Okay. Fine. Similarly, here also, if it has been asked to find the values of x square, so we can just greater than equal to 0. We can write x square minus 4 is less than equal to 0. Or I can write x minus 2 into x plus 2 less than equal to 0, right? And this x always lies between minus 2 and 2, okay? Which one? 7x is positive means 7. For 7, x is positive. Is it? Absolutely better. So it's like for domain, because it's a rational function, for domain, x plus mod of x is not equal to 0, right? Mod of x is not equal to minus x, isn't it? For what value of x, mod of x will be never equal to minus x? Obviously the positive values, right? Isn't it? If I take 2, this is never equal to minus 2, isn't it? If I take mod of 3, it is never equal to minus 3. You are right, section. So the domain will be what? Domain will be positive r, right? positive r. Absolutely better. So your answer is correct. 0, infinity we have. Fine. Domain is r positive. Absolutely. This is okay, everyone? Fine. Yes, all students, please let me know. Then I will give you some other questions. Today the function have already been published, so you can just go through it. Things becomes much more easier then, right? Okay. Suppose you have been given a function fx, which is equal to gx plus hx, or gx into hx, right? The plus minus. And you have been asked to find the domain. So both the cases, domain of fx will be domain of gx intersection domain of hx. So domain of fx is domain of gx intersection domain of hx, right? This is how it goes. Fine. Okay. Now, if it is given f of x gx upon hx, you have been asked to find the domain of fx, right? This is again domain of g intersection domain of h minus the values of x, right, for h is equal to 0. You have to minus the values of x, which makes hx equal to 0, right? Suppose you have been given a question. Example, fx is equal to root 3 minus x plus intersection beta, intersection. Both the cases it is intersection. All the 4 cases it is intersection. If it is plus minus, no problem. Okay. 1 upon log base 10 x, right? This is example number 1. Then we have example number 2, right? Okay, just this one. Minus sign, yes, second one. No, it is intersection beta. It is into. It is for plus minus both. It is for plus minus both, right? Okay, just find it out. Come on, fast, everyone. How will you do this one? So we have to find the domain in this. Yes, beta, you need to find the domain in this question, right? Intersection, beta, intersection. Are it? So previously I asked from B to A functions. Beta, it depends, Abhi. If they are asked you function from B to A, then you have to check whether the function is, the rules are applicable or not. Right away. Simple. If they have asked you f is a function from B to A, then you have to check the elements. Then B become domain and codomain becomes A. A becomes codomain. Is it? So if the image is left in B, how then? No. You are getting it confused now. See, if we have A, we have B, right? And you are talking about B to A. F is a function of B to A. So obviously, all the elements will be connected to elements of B, right? No elements will be left out in B. Okay? No elements will be left out in B. If it is left out, then it is not a function, beta. Right? So this is Gx, this is Hx. So we have been asked to find the domain of fx, right? Domain of fx and domain of Gx. Isn't it? So first of all, this one we can take in as 3 minus x is greater than equal to 0 or x is less than equal to 3. Here log base 10x is not equal to 0, right? So x is not equal to 10 to the power 0, which is not equal to 1. So x is not equal to 1, right? X is less than equal to 3. So how can you write it? You can write minus infinity to infinity, isn't it? We have 1, we have 3. So 3 can be filled up, right? We have this part, it goes like this. We have 1, which is like this. Okay? Isn't it? This way can write. Fine. We can go into the left hand side this way. Okay? So the answer will be what? Minus infinity to 3 minus 1. Is this clear? Yes. Fine. So you understood? It will be function will be like this, then we can go like this. Okay? Samaksh? Better, there are two things. First of all, this is like x is not equal to 1, isn't it? Why? First one, because the rational function. Again, my question is this a function? Is the domain correct? Again, very interesting one. I come across with this part now. Is the domain correct? Anyone can rectify my view? Is the domain correct? Why is the domain not correct? Anyone can tell me? Why is the domain not correct? Why is the domain not correct, beta? Yes, let me know. because it's 0. So, you know, we can't take the negative thing, na? Because x should be always greater than 0, right? Isn't it? So this can be how much? It can be 0, 3 minus 1. Is it? Right? What do you say? Yes, students, let me know. Why not equal to 1? So I've subtracted 1 now. It is how much? I have subtracted 1, right? Because log 1 is not defined. Na? If we write 1 upon log 1, if I log base 10 1, this is 0, right? So 1 by 0 is not defined. Na? Okay. So for log 1, log 0, fx is no. X cannot be 1. That's why I have taken this one. For log, you said for x greater than equal to 0. Yes, obviously x is greater than 0. No? That's why I have not taken 0. No? This is the open interval, right? 0 is not included, right? 0 is not included. Fine, so much? It's open interval, right? Okay. Is this clear, everyone? Fine. So we can add in domain and subtract 1. Yes. We can write in this way. No, we write always in the interval form, no? We write always in the interval form, beta. Okay? We write always in the interval form. Okay, everyone. Or we can write it in this way. See, we can write it in 0, 1, open interval, union 1, 3. Right? This is what I think Aryan has also given the answer. Is this clear, everyone? Is this fine? Any doubts, beta? Anything you want to ask, you can. Yes, let me know. All my students, let me know. Just have a look at it and let me know if this is okay. Yeah. Oh! Happy Children's Day. I'm not. Sorry. Oh. Happy Children's Day. God bless you. God bless you. Everyone. Huh? Sorry. So we're like, Okay. Not. Chalo, God bless you, everyone. Okay, enjoy. It's your day. Right. So I suppose this is clear to everyone. And one doubt was there of Mithun, that how to find the number of functions. I will come to that point. Okay. Fine. Not the number of functions. Then identify the types of functions. That is not possible, beta. So if possible, can you please add some questions of the chapters done in the test? Okay, then I will get back to you in the I will get back to you in the group itself. Okay, let me check. Sir, if possible, can you add some questions of the chapters done in the test in the videos, or you want some assignment sort of thing? Okay, you need questions on that. Right, so much. Absolutely, you are correct. Yes. I think modules will have around maybe 8-10 modules will have, maybe more than 10 modules. There are advanced package also, more than 10. But actually, in test form you are talking about. Okay, you want in test form. You need more questions as in a test form, right? For continuous revision. Okay, fine. No, you are talking about the number of modules, right? So modules may have different 3 chapters in a module, 2 chapters in a module, right? Okay, I got it. Yes, fine. Hemant? Okay, Aryan, let me check it out. We are on the 3rd module, yes? Yeah, we are on the 3rd module, absolutely. Fine. Which module do you have calculus? We'll do calculus later on. Don't worry. We'll start with calculus is a very big bang. Don't worry. First we understand function. Then we have permutation combination. I think we have binomial theorem. So we'll finish off class 11 first. Then we'll come to the second part. Okay. Okay. Which module do you have calculus? Maybe in the 5th one. 6th one. Maybe 5th or 6th, right? Okay, then I will end up the class now. And Aryan is asking, sir, can you have more tests? We'll just check it out, right? If things possible, then we can plot some more tests, or maybe in PDF form we can provide you, right? Let me check. Okay, don't worry. I will just go through it once and I will let you know. Fine. Okay then. So once again, happy Children's Day to all of you. God bless you, beta. And whatever your aim is, I personally, heartily, I want that your aim should be fulfilled, right? So these 2 years of yours are very important. Okay. So just utilize this time and just get your dreams done. Okay, fulfilled, right? By then, take care. God bless you, beta. Bye.